Let's talk a little bit about contactors. When you replace a contactor, there's some things you need to know. And if you don't want to watch the whole video, you need to know the number of poles, the coil voltage, and the load switch contact ratings, which has a lot of information connected to it. Now let's go through and break all this information down. We'll start first with C, the switch or contact ratings of the load. This is the one that has the most information connected to it. So these contacts, every time a unit calls for cooling, you get your 24 volts here and these points come in. And every time they make connection, they arc, they get worn, and every time it releases, it pops back up. This switch is controlling a load. And residential, you're looking at a compressor and a condenser fan motor. For commercial, it could be any number of things, tons of different things these can control. These also control heat elements, but this switch is controlling that load. And it's like a car. Every time you use the brakes, you start getting wear and tear on that car. So every time these are used, they get worn down. About 5 years is your average life out of these. So we need to make sure that this switch is able to handle our load. So these contactors we read on here is going to have a rating for it. And what I've drawn is an example of one of these contactors of what the rating looks like. So let's go through this real quick. It says VAC we're working with. You need to know what VAC you're working with. For residential, 240, this says up to 277 volts. Commercial, looking at 480, 600 volts. So that's the voltage of our load, what we're working with. We also have an FLA rating, which stands for the full load amps. This is going to be the compressed, for an example, the compressor RLA plus the condenser fan motor FLA. So we add both of those together. That's going to be how much we're going to need to be able to handle with these points. Plus, I like to add about 10 to 15% to make sure there's plenty in there. And then also we have to go with the LRA, which is the locked rotor amps, also known as starting amps of that compressor, and the inrush current. We can get that information off the tag of the unit. It'll have that written there. And then also for controlling heat elements, we have the RES, for example, resistive load, like heat elements. So we're going to break this down real quick. If I'm working on a residential unit and I got 240 volts or 208, 230, this is going to be the line I'm going to use. And then it says FLA of 25. Now there's a few things I can use in this. I can take a shortcut and be completely safe and look on the tag of the unit for the maximum overcurrent protection or the maximum fuse size. And I can rate my contactor for that maximum number and I know that I'm going to be good. If you don't have that to go with, you can take your FLA of your fan motor, add it to the RLA of your compressor, plus a little bit more percentage, 10% to be on the safe side, and that gives you your minimum you needed for your contacts. So this contactor right here on this example, I could handle up to 25 amps with this contactor. Now if I was working in the field and I had my fan motor of say 1 amp and my compressor is pulling 25 amps, we're looking at 26 amps or so, this would not be large enough for me. The next thing we want to look at is overlooked a lot in the field, but we want to make sure we match up the LRA rating. This is the locked rotor amps of that compressor, the maximum starting amps. We don't care about the fan motor. It's such a small motor. It has very little inrush current, but that compressor is heavy. It's got to get all that refrigerant moving, all that steel and metal inside moving. It's going to have an inrush of current of a lot of amps going into that inductive load. It's going to pull a lot of amps when it first starts up. This contactor in this example can handle up to 150 amps at startup. So I want to check on that compressor, on the tag of that unit, and that'll give me an LRA rating. I want to make sure that LRA rating of the compressor is less than the LRA rating of my contactor. So I don't only want to match up the FLA, I also want to match up the LRA to make sure that these points can handle what I'm working with. Now if I'm working with a heater, I can control 2 heat elements with this one. That heater, it's resistive amps. So we don't have an inrush of current. There's less arcing going on there. So if there's a resistive heater, a heat element, I can control 30 amps with that. So inductive load, I'm going to need these 2 numbers to work with. Electric heat element, I'm going to need this number to work with. And if you see, the resistive amps is usually more than your FLA. Now as I go up to, say, a 480 volt, I can handle less locked rotor amps. And if I go up to 600 volts, I can handle even less than that. This particular example has the same FLA regardless, but every contactor is different and it depends on that manufacturer of what they want to use. So this is what that means and how to use it. Now what I like to do in the field is I like to keep as little truck stock as I can in my truck that covers the most scenarios. So what I would usually keep, instead of having a 25 and a 20 and a 30 and a 35, I would usually stock a whole bunch of 40. This one right here is rated for FLA of 40 and the locked rotor amps of 240, resistive heat of 50. So this contactor here isn't but about maybe $5 more than this one right here. This one can handle 40 amps. So if this one handles 40 amps, I could replace this old one that only handled 25. It's actually going to last longer. It's a heavier duty, it's built better, the points are built better, it's a higher quality contactor. So by carrying a whole bunch of these, I'm putting in a better quality part for my customer. Their system's going to last longer. I don't have to worry about callbacks, and the price difference is really negligible. Now also I'm going to carry maybe one, maybe two of the higher ones, maybe a 50 amp or a 60 amp. It's really rare now to see those unless you get into some commercial situations. Back when I first started in this industry, we would have a lot of contactors, these old compressors from the 80s, and they would just be pulling a massive amount. We'd have to use those big contactors. But now most of them are pulling less than 25 amps. So if I carry this 40 amp contactor with me, I know that I'm going to be good. So it would be an upgrade for these, and I could be equal with an actual 40 if I needed to replace that. So this switch can handle so many amps, and I need to make sure the load I'm controlling with this switch is less than my switch or equal to that switch. So that's what this information means. If you look on the contactors, you'll see a ton of different numbers on there. Just make sure your contactor is rated for higher than what you're trying to control. And the same thing goes with the resistive heat element. So that's very, very important and one of the most overlooked things. So I wanted to start there first. The next, it says coil voltage. This is going to be my control voltage. In another video, we took a capacitor, the transformer apart, and we showed how the control coil was separate from the switch side. This looks like a coil of wire that's all wrapped up. If we look really close over here, we can see that this wrap of wire, but it really isn't just pure copper. There's a coating on that. It's got a type of varnish coating on there that makes that wire run, electricity run in an electromagnetic field. When you go to supply house, they're going to have boxes of these, and they're all going to be stacked up. And if you look at two contactors, they'll look 100% identical. What you're going to have to do is actually read on the tag for one, the coil volts as well as the contacts to make sure they're the same. Both of these are rated for coil 24 volt VAC. So if we look on this tag right here, we see where it says coil VAC 24 volts. But not all of them are that way. So when we get into commercial, we end up with our coil voltage being 120, 208, 230, 240, or even 480. So let's see if we can see this one. It says coil voltage is 190 to 220 volts for 50 hertz, but we're in the US, 208, 240 volts, 60 hertz for the coil voltage. So that's the coil voltage. A lot of people that's done residential only think that all contactors are 24 volts, but when you get commercial, this is 240 volts that go to the side of this. If I put 240 volts to this 24 volt coil, it's going to catch on fire, smoke, it's going to be very bad. If I put 24 volts to this coil, nothing's going to happen. There's not enough potential difference to even make this contactor pull in. So if we open this guy up and take a look at it, it looks identical. I could find another one here. This one's 24 volts, and if we take a look at them, they look identical. The only way you're going to know a difference in these is if you actually read the tag on it. And here we have, this one says, on the tag, they put it upside down, coil voltage 208, 240. I don't know if you can see that in the camera. And then this one, the tag is completely missing. That one doesn't give us any information. So the reason I'm making a big deal out about this is me as a young tech, I went out to a job and I found out that I had 24 volts to the contactor, but the contactor was not pulling in. So it's obviously a bad contactor. So I went to supply house. I didn't have one in my truck, which I should have. Went to supply house, grabbed one. It looked exactly like what I needed. I thought I was good. I went back to the house, I hooked it up, and it didn't work. But I was smart. I grabbed two, so I put the second one on, and it still didn't work. So I called technical support, and this is back in San Angelo, Texas, and I called a guy named Brian, and Brian is a brilliant man, and I called him and I said, hey, I'm having a problem, and I explained everything. He said, what's your coil voltage? I said, well, it's 24 volts. He goes, what does the contactor say? I said, it's 24 volts. He said, are you guessing or are you telling me? I said, I'm telling you, I know it is. He said, oh, you that know so little, look and actually read what it says. And I read on it, it says coil voltage 208, 240. and he laughed. He got a good chuckle out of it, but he taught me a lot, not knocking him at all. Brian Miller, awesome man. So anyways, then that was the moment I learned that not all of these are 24 volts. So I'm telling you so you don't make that mistake. When you go to supply house, you need to read on there to see what coil voltage it is. Residential, it's going to be 24 volts. You get into commercial, it could be 24, 120, 208, 230, 240, 277, or 480 volts. It's very important for you to know that. And the last thing on the list, this is easy to identify, but it's going to be the number of poles. So number of poles, here's a contactor that has what we call a one pole. Some people call it a pole and a half. I only have one switch. I'm only breaking one side. The other side right here is I think they call it a stent. It's permanently connected. There's no switch going on there. So this side just connects line 2. There's nothing that breaks it. So this side is the only side that breaks. So you can replace a pole and a half with a double pole depending on the unit. I can just replace these. In the field though, I like to make sure I have one contact that does multiple things. So instead of stocking these in my truck, I would always keep these in the truck. But wait, before we get too carried away, we have to understand that I can't always do it that simple. If I have a crankcase heater, in other words, there's a heater that stays on when the compressor is off, and when the compressor is running, the crankcase heater is off. And we'll get into that in another video. I can't use a double pole contactor. I have to make sure one side stays. So the next question is, how can I make this contactor, double pole contactor, replace this single pole contactor? And the answer is pretty simple. All we need to do is grab us a little jumper wire, and I wire this one in the exact same way that I'm wiring this one in. This one only breaks one side, this one stays constant. So all I have to do is put a jumper wire from one side here and bring it down to the bottom side right here. Now I've made this 2-pole contactor into a pole and a half contactor. This side here will actually never go bad. What's great about that is if you have a customer and after 5 years, you could actually swap it around, turn it around, and the side that's never gotten any arcing because it never shut on and off will actually still, you could make the side that was burnt here, the side that was never used here, and get a whole lot more life out of it. But if you have a crankcase heater, you're going to need to do this. If you don't have a crankcase heater, I could take this one out and just simply put this one in just like it is, and it will work fine. So the question is, you can replace this one, but if you have a crankcase heater, you need a jumper wire. If you don't have a crankcase heater, take this one out, put this one in, you're set to go. So single 1 to 1.5 pole, they also call this a dead man's pole. And the reason is on a ladder diagram, a 2-pole contactor is breaking both sides of the circuit, so it's isolating it completely. On a pole and a half, we're only breaking one side of the circuit, which is all we need to break. You break any one side of the circuit stops working. However, if you get people with a bad habit of working on units without checking for voltage first, or they're not shutting the power off and using the safety protocol, the unit shuts off and they assume that it's off and they go and grab it and they're grabbing the other side of the wire and they're getting shocked with half that current, which is a bad thing. So they call it a dead man's pole because if you're not being careful, it will shock you. However, if you do the safety protocol, it won't matter if it's a 1, 2, 3, 4, it doesn't matter what pole it is. So sometimes a 1 pole, some people call it a pole and a half, some people call it a dead man pole. All of them though are this that breaks only one side. Now let's talk about the double pole. We already talked about how to replace a double pole contactor with, replace a single with a double pole, but these are really nice. It's just simple. This is one pole here. This is a separate pole right here. So it's 2 separate poles. And on a heat element, this could be one heater and a separate heater, but most of the time for residential condensing units, line 1 comes in, we go to do work, we come back home to the opposite side, line 2 goes home back to the disconnect. So it's pretty simple. But also we have what we call 3-pole contactors. 3-pole contactors have 3 distinct poles in it. So if we look at this 3-pole contactor, we have pole number 1, pole number 2, and pole number 3. Usually though, when you look at them, it's going to look something like this, where it has this piece here in the middle. It's got this cover on it to prevent bugs and stuff from getting into it. You can use a 3-pole contactor to replace a 1.5 pole. You can use a 3-pole contactor to replace a double pole. So I have line 1, line 2, and I just don't use this at all. So It's not even there. The problem is that these 3-pole contactors cost significantly more than a double pole. So have I used a 3-pole contactor in residential to replace a double pole? Yes, absolutely. Lost a little bit of money on that one because these cost so much more. I'm just not going to use this 3rd pole. It's just sitting there, just kind of a waste of money really. But if it's midnight, I'm in the customer's house trying to get them cooling or heating for that matter, I'm going to put in what works. Now another thing you can use these 3-pole contactors for is resistive heat elements. I control one element, control a second element, and I can also control a 3rd heating element with this 3-pole contactor. But mostly what these 3-pole contactors are for is for commercial work. You have line 1, line 2, and line 3. We call this 3-phase power, and these controls compressors and blower motors with 3-phase. So that's the difference when you're replacing a contactor. You need to know number of poles. Does it have a crankcase heater? You need to know your coil voltage. Make sure you're matched up with the correct one you're putting in. And your switch and contacts need to be rated higher than or equal to your load. And then that goes into the full load amps, LRA locked rotor amps, and REZ resistive amps. And I want to special thanks to National Technical Institute. They're letting me use their classroom to make this video.